Hi everyone, myself Dinesh, working as assistant professor in the Department of Mechanical Engineering and from SNS College of Technology. In this video series, we are seeing the subject solar energy utilization. Okay, in this the first part we have seen the sun and earth relationship. Okay, this is also a continuation about that. In that we have seen the how days and day and night occurs because of earth rotation, and how the season occurs, that means the weather pattern changes which are related to sun revolution. Okay, in this we are going to see earth orbit and the phenomena of seasons. Okay, so first we can divide it into two. Okay, as you see in this diagram, first one we call it as elliptical orbit. Okay, first we call it as elliptical orbit. Okay, the elliptical orbit is the earth follows an elliptical path. Okay, everyone knows the earth follows an elliptical path around the sun, meaning that the distance between our planet and the earth is not constant. Okay, so the distance keep on varying from place to place. At its closest point, known as perihelion, the Earth is approximately 147 million kilometers from the Sun. Mostly it will occur at the time of June 3rd. Okay, so at the same time, at the farthest part, the distance will increase from 147 to 152 million kilometers, which will probably occur during the 4th of July. Okay, this is what we call it as the sun's and earth relationship based on the elliptical orbit. Okay, the approximate distance, closest distance between the sun and earth is 147 million kilometers, but whereas the further distance between the sun and earth is 152 million kilometers, which will occur during the 4th of July. So the second one is impact of the distance variation. Okay, so due to this distance, our earth will have lot of impact, which means the change in climate, the change in the intensity of the radiation. These are all the some of the impact which will occur on our earth. Okay, while this varied distance does cause minor fluctuation in the amount of solar energy received, it is important to notice that these variations are not the primary driver of sun season. Okay, the difference in solar intensity due to orbital SNM is relevantly small compared to the effect of Earth's axial tilt. Okay, it's also the Earth tilt is also we have to consider. So the next one is the role of axial tilt in creating season. Okay, as we know that, as you seen in this diagram, uh, the earth is rotating around the sun, not at a straight. It's tilted at an angle of 23.5 degree. Okay, so this is also responsible for various seasons. Okay, the earth axis is tilted at a constant angle of 23.5 degree to its orbit plane around the sun. Okay, this is the information which we have already seen. So this axial tilt is the fundamental reason for the earth experiencing various seasons. Okay, as the earth revolves, different part of its surface are angled either towards or away from the sun, which lead to variation in the intensity and duration of solar radiation throughout the year. This tilt directly impact the design and orientation of solar panel to maximize energy capture. Okay, so the tilt is also plays a major factor when it's come to the variation in season and also in the climate, which occurred in most of the different part of the earth. Okay, so this is also one of the relationship, important relationship between the sun and earth. Thank you.